In this lesson, we'll be discussing radicals, reducing, rationalizing, adding and subtracting, and multiplying radicals. So first let's define what a radical is. A radical is an expression that uses like the square root, the cube root, the fourth root, one of those symbols. Some examples are this one, which is a square root. Then the next one is cube root, fourth root, and then fifth root. And then technically we could go all the way to the nth root, n being any number. Okay, so some definitions: the little n up in the check mark of your radical symbol, there's a number there, so that number is called the index. If you don't see a number, then there's an invisible 2. In fact, we call it a square root. Square means 2, like when you square something. But we just have square roots are so common, we just don't write them. But that would be the index n. The letter A, in this case, is called the radicand. And the radicand is just the name for the number underneath the radical symbol. So the nth root of a is pronounced the nth root of a, and it means the value when raised to the nth exponent equals a. So let's give you an example of that, because that's a whole lot of letters and that's kind of hard. So when you have a little 3 here with the root 8, it's pronounced the cube root of 8, and it means the value that when cubed it equals 8. So what number cubed gets you 8? Well, that's 2, because 2 times 2 times 2 is 8. So therefore we can say that the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that's how a root works. Now we have a lot of perfect squares, cubes, fourths, and fifths that we use quite a bit, so you want to memorize these facts. So let's get you started on a couple, and then I'm just going to pause the video and let you fill them in. So let's say on perfect squares, because 1 squared is 1, 1 times 1 is 1, that means the square root of 1 is 1. 2 squared is 4, therefore the square root of 4 is 2. 3 squared is 9, therefore the square root of 9 is 3. And a lot of these numbers you've seen on your multiplication tables and such. Okay, I'll go ahead and fill the rest in a minute. Let's look at perfect cubes here. 1 cubed is 1 times 1 times 1, which is 1. So therefore the cube root of 1 is 1. 2 cubed is 8, so 2 times 2 times 2 is 8. Therefore the cube root of 8 is 2. And one more. 3 cubed is 27. Therefore, the cube root of 27 is 3. So I think you get the pattern now. So I'm going to go ahead and have you pause your video and just go ahead and fill them in, and then I'll scroll down and do the same. Now I'm going to scroll and do the next section. So go ahead and pause the video here and fill in the rest of these. Notice that I didn't give you every single one. In squares I went all the way from 9, 10, 11, all the way to 15, 16, and then I skipped 17, 18, 19, and just did 20 and 25. The ones I'm giving you here are the ones that come up an awful lot. So like on perfect fourths, I only did 1 through 5, and then I skipped to 10. On perfect fifths, the larger the index, the numbers on the inside get really big really quickly, so I only gave you 3 there. So go ahead and get these memorized, because you'll be using these an awful lot, and if you don't memorize them, then it's just going to take you a lot much longer to do the assignments. So the next one, I'm just going to practice what is the square root of 49. So there's an invisible index of 2 here, so what number multiplies by itself twice gets you 49, and that answer is 7. The next one, what's the cube root of 125? What number multiplies by itself 3 times to get 125? And that's 5. The fourth root of 16. This one is a tricky one. I'm going to scroll back here for just a second. The 16 can be a little tricky, because 4 squared is 16, but also 2 to the 4 is 16, so just be careful there. The other ones you want to be careful on are 8 squared is 64, but 4 cubed is also 64. So I'm just going to write a note. Just be careful of what you're thinking about here. So when I'm talking about the fourth root of 16 for this problem, I'm thinking what multiplies by itself 4 times gets you 16, and again the answer is 2. The next one, the fifth root of 32, that's 2, because 2 times 2 times 2 times 2 times 2 is 32. The next one looks really hard. It's like a fraction. You're like, oh no, I can't do it. It's not that bad. If you just break it up into the top, the square root of the top over the square root of the bottom. The square root of 1, that's a perfect square, that's 1. What's the square root of 81? Well, that's 9. So the square root of 1/81 is just 1/9. Same thing on the last one, the cube root of 1 over the cube root of 64. Cube root of 1 is 1. The cube root of 64, that was one I told you to be careful of. What multiplies by itself 3 times to get you 64? And that's 4. Not 8. A lot of times people want to just rush in anytime they see 64 make it an 8, and in that case it wasn't true. The next thing that we're going to talk about is negative radicands with even and odd index. So let's consider the square root of negative 16. So this is a square root, so I'm thinking 2 times. So let's see, 16. We talked about 4, right? 4 times 4 is positive 16. So that one doesn't work. How about negative 4? Negative 4 times itself, negative 4. That still gets you positive 16. And what are we looking for here? We're looking for negative 16. We're looking for what number multiplies by itself to get a negative 16. Well, as it turns out, to multiply to a negative, you need one positive and one negative. Well, that's not itself, is it? 4 and negative 4 is not itself. So there is no real number that the square root of 16 is equal to. Nothing in our real number system. But let's consider the next one, the cube root of negative 27. Now, because the index here is different than the index here, we might have a different outcome. Let's just kind of ponder this. Let's see, the cube root of positive 27 is 3. So let's try negative 3. Negative 3 times negative 3 times negative 3. 3 times. So negative times a negative, that's a positive 9, and a positive times a negative, that's negative 27. So it worked. Negative 3 times itself 3 times truly gets me negative 27. So how come one of them didn't give you a real answer and the other one did? That's confusing, right? So here's the answer. If you take the even root, that's talking about the index for the square root is even, then there is no real solution if you're trying to take the even root of a negative. But if you're trying to take the odd root of a negative, like the cube root of a negative, then the solution is just a negative number. So let's practice this here. And the reason why that works is because when you have 2 negatives and you multiply them, it turns out to be positive. When you have 3 negatives, the first 2 become positive, but you still have that leftover one. So anything that's odd, when you multiply odd number of negatives, you'll get a negative answer. So let's practice this. The square root of negative 49. Okay, so what is that index? That index is 2, an invisible 2. And 2 is even. So therefore, the square root of negative, there is no real number that when you multiply it by itself, you're ever going to get negative 49. Now, the next one, the index is odd. 3 is odd. So the cube root of negative 64, it just means negative, the answer, negative, and the cube root of 64 is 4. So negative 4 is your answer. And then if you're like, I'm not so sure about that, you're welcome to multiply negative 4 3 times. It will give you negative 64, and then you'll see that it is true. On the next one, we have the fourth root of negative 16. Because the fourth root is even, are we allowed to have a negative inside the radical if it's even? Nope, you're not. So the answer is no, not a real number. No real number that works. Okay, the next one is the square root again. So it looks like it's even again. Well, can we take the even root of a negative? Nope, so it's not real. And the next one we have 5. Okay, 5 is odd. So are we allowed to take the odd root of a negative? Yes, you are. The answer is just going to be negative, and then whatever the answer is in this case, 2. And then the last one, 3, the index is 3, which is odd, which means we are allowed to take the cube root of an odd, cube root of a negative, so the answer is just going to be negative something. The cube root of 27 is 3, so the answer is going to be negative 3.